Okay, so let's talk about reversing a linked list, and we are doing the reverse of linked list in an iterative manner. So let's say if there is, so let's take example. So example of a linked list. Let's say if there is no list, no node inside a linked list. So if there's no node inside a linked list, we don't need to reverse anything. We can just return. Or if there is just one node in the linked list. So let's say 5 is there, and this is pointing to null. And if there's only one, then we don't need to do anything. We can just reverse. So these are the two base conditions which are there. Let's say, so in those cases, we'll just return. In the third case, let's say if there are multiple nodes in the list. So let's draw the linked list. So we'll say 5, and let's say 7, and let's say 3, and let's say 1, which is pointing to null. Okay, so we have this list, and the head is over here. So in this case, what we'll do is, what we have to do is we have to reverse all these pointers. So we have to reverse all these pointers and then move the head and move it to 1. So that way we can actually reverse the linked list in order of n without making any changes or without taking any extra memory. So how we do it is we basically take 3 pointers. Why do we need 3 pointers? Is because, like, if we break a list, then we need to know where this if we break a link, we need to know where that link is going. So if 5 is going to back, so then we need to know where is the back. And then if we break this list, then we don't know where the front one is. So we need a list for the we need a node for the front one. So we'll take 3 different nodes. One will be the back, which will be pointing to null, and the second one will be the middle, which is pointing to the head, and the third one would be head.next, which is the front one. So what we'll do is we'll go in a while loop while the front is not equal to null. While the front is not equal to null, what we will do is we will actually move the middle.next, we'll move the middle.next to back. So we'll move the middle.next to back. So let's do that. Okay, we did that. Next, what we do is we move the back to middle. So we'll say back is equal to middle, and then we'll move the middle is equal to front, and we'll say front is equal to front.next. Okay, so let's do that. So we have moved the middle.next to back, and then we need to move back to the middle. So back node will basically go to the middle node, and then the middle node will basically move to the front node. Okay, and the front node will basically move to the front.next. Okay, so at this point also front is not equal to null, so it'll repeat the process again. So it'll break the middle's node, so it'll break that and then move it to back. Okay, then it will move the back to the middle node, and then it will move the middle node to the front node, and then it will move the front node to front.next, which is over here. Okay, the front is still not equal to null, so we'll repeat the process again. So we'll do this, and we'll move it to back, and then we'll move the back to the middle. Oh, sorry. And then we'll move the middle to the front, and we will move the front to front.next, which is equal to null. So at this point, this loop will actually be over. So once this is actually over, what we'll do is, since the middle dot next is pointing to null, we'll say middle dot next will be equal to back. So instead of that pointing to over here, it will actually start pointing to the back node. And then the head is still pointing to 5, so we'll say head will be equal to the middle node. So head will move from here, and head will basically come over here. So at this point, we have the head node, which is pointing to 3, and then 7, and then 5. So basically, we have reversed all the nodes. So that is how we'll write the code. And let's write the code down.